Hello students, welcome for another session of our class 9th Maths, Chapter 2, Polynomials and Factorisation. Exercise 2.1. In our previous session, we have completed 2 bits of the exercise 2.1. Let us continue with the next bit, that is third one in part 2 of the exercise 2.1. So the third one is given like this. Write the quotient of x cube in each of the following. There are some expressions, algebraic expressions are given. In that we have to identify the coefficient of x cube. So let us see. The first algebraic expression is given like this: x cube plus x plus 1. Where is x cube? First identify x cube. Here x cube. What is meant by quotient? What is the integer which is the in front of x cube? Here no integer there. That means it is 1. No integer there. 1 into x cube is x cube. So quotient of x cube. Here the quotient of x cube. Coefficient of x cube. It is what? Here no number is written, but there is 1. 1 into x cube is 1. X cube. That is why the quotient of x cube is here 1 only in this. Next one you see. 2 minus x cube plus x square. We need to focus on only x cube. The terms which is x cube, in front of it, whatever the integer is there, that will become the quotient of that x cube. So x cube, in front of it, nothing is there. You have to treat there is 1. Along with the sign, you have to write minus 1 x cube. Minus 1 x cube. So coefficient of x cube is in this expression, that is minus 1. Minus 1. Next, third one you see, square root of 2 into x cube plus 5. Only we need to focus on x cube term. X cube term, what is the quotient in front of x cube? Square root of 2. So this is the coefficient of x cube in this expression. Coefficient of x cube is in this, what is that? Square root of 2. Next, fourth one you see, 2x cube plus 5. Only focus on x cube term. In this term, in front of the x cube, whatever the integer is written, that will become the quotient. So coefficient of x cube is here only 2. Next one is fifth one. Pi by 2 into x cube plus x. Focus on x cube term. X cube in front of it, whatever the number is written, that will become the quotient. So in this, coefficient of x cube is this entire term, pi by 2. Next one you see, x cube minus 2 by 3 x cube. In front of the x cube, whatever is there, the total will become the quotient. So quotient of x cube is, what is that? Minus 2 by 3. Along with the sign we need to write. Next, 2x square plus 5. In this entire algebraic expression, there is no x cube term at all. So there is no x cube term at all means x cube quotient is nothing is there. So that is 0. So coefficient of x cube, in this term there is no x cube term at all. So that is why there is no quotient. X cube into 0, it will be entirely 0. X cube term becomes 0. There is no x cube term means the quotient of x cube term is what? 0. So x cube is 0 here. In this there is only constant polynomial. I already told you constant polynomial degree is 0. There is whatever the variable you keep here, that variable's degree is 0. X cube term is not at all there in this. So the degree is not there at all. The x cube term only not there at all. The quotient will not be there at all. So quotient of x cube term, there is no x cube term in it. That is why x cube quotient is 0 here. Hope you all understood what is meant by quotient of any variable. Whatever the variable is asked to write the quotient of it, what is involved, the integer which is written in front of it, that is called the quotient. So hope you all understood by looking at these all expressions how to identify the quotient of a particular term. Hope you all understood with this question. Let us move on to the next question. See the next question. Classify the following as linear, quadratic and cubic polynomials. There are some polynomials given. We have to classify them, which is linear, which is quadratic, which is cubic polynomial. How do we classify the polynomials as linear, quadratic and cubic polynomial? We already discussed in our previous session. Based on the degree of the variable only, we can name the polynomial as linear, quadratic or cubic or fourth degree, fifth degree, nth degree. That is means the variable which is involved in the algebraic expression of the polynomial, the variable's highest degree is what? If the highest degree is 1, that is called linear. If the highest degree is 2, that is called quadratic. If the highest degree is 3, that is called cubic. If the highest degree is 4, that is called fourth degree polynomial. If the highest degree is 10, that is called 10th degree polynomial. So actually based on the degree of the variable, we can classify or we can name polynomials as linear, quadratic and cubic polynomials. So let us see these are 6 polynomials which are given. First one 5x square plus x minus 7. The next one x minus x cube. The third one x square plus x plus 4. The next fourth one x minus 1. Fifth one 3p. Sixth one pi r square. Here r is a variable. See, the different polynomials have different variables and their different degree. Based on the variable's highest degree only, we can name that as linear or quadratic or cubic or whatever the degree polynomial. Now, in this question, they asked us to classify these all 6 polynomials as linear, quadratic and cubic polynomials. Let us find first linear polynomial. What are linear polynomials? What are quadratic polynomials? Quadratic. Cubic polynomial. So to say linear polynomial, the degree should be 1. To say quadratic, the degree should be 2. To say cubic, the degree should be 3. What is meant by degree? Actually, the variable's exponent. Suppose a polynomial contains number of terms. In all the terms, you have to check the variable's exponent. Whichever the exponent is highest one, that is the degree of the entire polynomial. Polynomial may contain number of terms. In all the terms, you have to look at the variables, and the variable's highest exponent only becomes the degree of that entire polynomial. Based on the degree only, we name them as linear or quadratic or cubic or any degree polynomial. So now out of these all 6 polynomials which are given in this question, let us check what are the degrees of those polynomials and the polynomial comes under which, whether it is linear or quadratic or cubic, we have to classify them. First one we see 5x square plus x plus minus 7. Here, what is the variable actually? X is a variable. How many terms are there actually? 1, 2, 3. 3 terms are there. In all the terms, the variable's exponent you have to see. First term variable is x and its exponent is 2. Second term variable is x, its exponent is 1. Third term there is no variable at all, it is a constant term. So what is the exponent highest? 2 is the highest exponent. So if the degree is 2, it is called as quadratic polynomial. So what is this 5x square plus x minus 7 is quadratic polynomial. 5x square plus x minus 7 is quadratic polynomial since its degree is 2. Next, x minus x cube. The first term is x, its degree is 1. Second term is minus x cube, its degree is 3. There is same variable in the 2 terms, but the degree of the first term, the degree of the second term is 3. Entire polynomial's highest degree is 3, so it is a cubic polynomial. So x minus x cube is a cubic polynomial. Since the degree is 3, it is called as cubic polynomial. Next, third one, x square plus x plus 4. There are again 3 terms, but in all the terms, the variable you see, x is the variable. Here x is the variable. Here there is no variable. but the degree of the first term is 2, degree of the second term is 1, the degree of the third term is 0, the highest degree is 2, so it is also a quadratic polynomial. So it comes under quadratic polynomial. X square plus x plus 4, which is quadratic polynomial. Next one, x minus 1. Here there are two terms. The first term, what is the variable is that x. Second term, there is no variable, it is a constant term. So first term, variable x, its exponent is nothing, that means it is 1. There is no number is written, means you have to imagine it as 1. The degree of this polynomial is 1. Since the degree of the polynomial is 1, it is called what? Linear polynomial. It falls under linear. X minus 1. Here next one, 3p, only single term. What is the variable in it? P is the variable. What is the exponent of it? Exponent is not, no number is written. That means you have to imagine it as 1. So it is a linear polynomial. This is also a linear polynomial. Next, pi r square. Here r is a variable. Pi is a symbol actually. Pi is a symbol we use in geometry to represent the ratio between the circumference of the circle and its diameter. That is why we obviously take the pi value as 22 by 7. That is approximate value actually. It is a irrational number. So pi is a symbol, r is a variable. Here we have to treat r as a variable. So only one term is there. The variable is r. Its degree is 2. So it is a quadratic polynomial. Pi r square. It's a quadratic polynomial. How can we classify the polynomials as linear polynomial or quadratic polynomial or cubic polynomial? Only by checking the variable's exponent. If the variable exponent is 1, linear polynomial. If the variable exponent is 2, that is quadratic polynomial. If the variable's exponent is 3, that is cubic polynomial. Hope you all understood how to identify the polynomial of which type. Let us move on to the next bit. See, next one given, write whether the following statements are true or false. Some statements are given. By reading the statements, we have to decide whether the statement is true or false. The first statement is given, a binomial has two terms. Binomial. How you classify that polynomials as monomial, binomial, trinomial, multinomial? Based on the number of terms only, we classify the polynomials as monomial, binomial, trinomial, multinomial. What is given here? A binomial has two terms. Yes, the polynomial which has two terms in it, then only we call it as binomial. So, a binomial has two terms is a correct statement. So, it is a true statement. True statement. Next, every polynomial is a binomial. No, we cannot say every polynomial is not a binomial. It can be a linear polynomial, it can be a cubic polynomial, it can be a 4th degree polynomial, it can be a 5th degree polynomial. A polynomial may have different number of terms. All polynomials may not be binomials, but all binomials are polynomials. Binomial means the polynomial with two terms is called binomial, but that doesn't mean all polynomials are binomials. So, polynomials can be linear polynomial, quadratic polynomial, cubic polynomial, nth degree polynomial, that are based on the degree of the polynomial. Here binomial, monomial, trinomial, these are multinomial based on the number of terms. Here what is given? Every polynomial is a binomial. Binomial means it should contain only two terms in it. It should contain only two terms in it. But polynomials may have number of terms based on their degree or based on their number of terms. We name differently. But binomials, all are polynomials, but all polynomials need not to be binomials. It may be trinomial, it may be a monomial, it may be a multinomial also. So, which is a false statement. All polynomials are not binomial. Binomial means what? The polynomial which contains only two terms in it, then only we call it as binomial. But that doesn't mean all polynomials are binomials. Next, third statement. A binomial may have degree 3. Of course. A binomial means what? The polynomial which contains two terms in it. It is called binomial. Whatever the degree it may be, doesn't matter. Degree doesn't matter here. The polynomial which contains two terms in it, that is called binomial. It may have degree 3 or it may have degree 100 also, no problem. So, a binomial may have degree 3, which is a true statement. Next, degree of a zero polynomial is 0, of course. Degree of a zero polynomial. 0 is a constant number. 0 is an integer which is not a variable. There will be no degree at all. So there will be no variable. 0 into anything is 0. So its degree is also 0. So it is a true statement. The degree of x square plus 2xy plus y square is 2. Yes, of course. See the first term. What is the variable? X square is there. X is the variable. The degree of this term is 2. Here there are two variables involved, x and y. X variable degree is 1, y variable degree is 1. So this entire term degree is 2. Here the third term y square is there. What is the degree 2? So maximum exponent is what? 2 only. So there are 3 terms, right? But all the terms containing their exponents is 2 only. So the degree of this polynomial is 2. It is a true statement. Next, pi r square is a monomial. Yes, pi r square. It is only single term. There is no other term involved here. Only one term is there. So it is a monomial. The polynomial with a single term is known as monomial. So it is a true statement. Hope you all understood how we decided these are true statements or false statements. Based on the number of terms and based on the degree, we know the classification of the polynomial so that we can decide the statements which are true or false. So let us move on to the last question of this exercise 2.1. Question number 6. Give one example each of a monomial and trinomial of degree 10. Monomial, trinomial. How you can decide a polynomial is a monomial or a trinomial? Based on the number of terms. If only single term is there, that is called monomial. If there are 3 terms in it, that is called trinomial. If there are 2 terms in it, that is called binomial. If there are more than 3 terms, that is called multinomial. We need to write the example of a monomial and example of a trinomial, and again their degree should be 10. Degree is the variable which we are using in the writing polynomial. That variable's highest exponent should be 10. The variable's exponent should be 10. Then we call the polynomial is of degree 10. We have to write 2 polynomials. One is monomial, one is trinomial, and both should have their degree as 10. So let us write the monomial of degree 10. Example for a monomial of degree 10 is, you can write any variable, you can use any variable. I am using the variable x here. So monomial is only one term. So I am using 5x to the power of 10. There is only one term, there is no plus or minus connected with other term. Only single term is there. The variable which I am using x, its exponent is 10. So it is an example of a monomial of degree 10. Or you can take another one also, minus 3y to the power of 10. This also a monomial, only one term. Here y is the variable and its degree is 10. Like that. You can write anything. Next, examples for a trinomial. Trinomial means this algebraic expression should contain 3 terms in it. Trinomial of degree 10. That means whatever the variable you are using in it, that variable's highest degree should be 10. Here I am writing two examples. Of course, there are asking only one example, but I am writing 2 examples. First one, 2. I am using another variable here, p. 2p to the power of 7 minus 5p to the power of 10 plus h. Any other one. Constant term. There are how many terms? 1, 2, 3. 3 terms are there. That is why it is called a trinomial. And the first term variable exponent is 7 third term there is no variable, the exponent is 0. It's a constant term. So how many terms are involved in it? Since 3 terms are there, it is a trinomial, and the variable which I used, it is p. Its highest degree is 10. So it is a polynomial of 3 terms. So it is called trinomial, and the variable's highest degree is 10. That is why this is a polynomial of degree 10, and there are 3 terms in it. It is a trinomial. So number of terms are, how many are there? Number of terms are 3. 1, 2, 3. 3 terms are there. No need to write the number of terms here. Just they are asking us to write the example. Another example you can write using the another variable, any variable. Suppose k to the power of 3 minus 2 k to the power of 10. 10 should be there compulsory. Plus k square also. There is no constant. There are 3 terms, k square, k cube and minus 2k to the power of 10. The highest degree is 10. It is also a trinomial, and the variable which I use is exponents. The first term it is 3, the second term it is 10, the third term it is 2. The highest degree is 10. So this is also a trinomial of degree 10. Like that any variable you can use, but the number of terms should be 3 to say it is a trinomial, and the degree of the highest degree of the variable should be 10. Hope you all understood about all the problems of this exercise 2.1. With this we will conclude our exercise 2.1. When we meet in the next session, we will go with another topic. Hope you all understood today's session. Thank you very much.